Simplifying radical expressions. A radical expression is one that includes a square root symbol. This symbol indicates the positive square root of the number underneath it. To indicate the negative square root, one must include a negative sign before the symbol. There are three possible cases when simplifying radical expressions. In the first case, the expression cannot be simplified because the number under the symbol has no perfect square factors. In the second case, the expression simplifies to a whole number because the number under the symbol is a perfect square. In the third case, the expression can be simplified by factoring out perfect squares. Once you have factored out perfect squares, you can move the square roots of those factors to the outside of the symbol. Here are some examples. 25 is a perfect square, so the square root of 25 is a whole number. 5 times 5 is 25, so the square root of 25 is 5. I can input this into a calculator and get the same answer. The square root of 72 can be factored into two factors, one of which is a perfect square. The square root of 36 times the square root of 2. The square root of 36 is 6, but the square root of 2 cannot be simplified, so the final answer is 6 times the square root of 2. This is an irrational number. It is the exact answer. To get an estimated answer, you could input the square root of 72 into a calculator. It would return an endless decimal answer that can only be rounded to whatever number of decimal places you choose. A calculator cannot give an exact answer to an irrational number. In this example, there's already a number on the outside. Leave the -2 on the outside. Factor square root of 50 into the square root of 25 times the square root of 2. The square root of 25 can be simplified to be 5. So we get -2 times 5 on the outside times the square root of 2. The final answer then is -10 times the square root of 2. This is the exact answer. The calculator can only give an estimated answer. Try inputting this answer or the original problem into a calculator. In either case, you will get the same answer, an endless decimal which you will need to round. We'll go ahead and round it to the third decimal place. Now pause the video and try the next one yourself. Now that you have tried it, check your work. Leave the 4 on the outside. The square root of 9 is 3. 4 times 3 is 12. Since this answer is a rational answer, the calculator gives the same answer. The last two examples cannot be simplified. 13 is a prime number which cannot be factored, so the square root of 13 is the answer. When we enter it into the calculator, we need to round it because we get an estimated answer for this irrational number. Similarly, the square root of 7 is a prime number and cannot be factored, so our final answer is the same as the beginning, 5 times the square root of 7. Also an irrational number whose calculator answer will need to be rounded. But what happens if there are variables in the expression? To simplify a radical expression with variables, we need to understand that x squared equals x times x. Thus, the square root of x squared is x. The square root of any even power will be half of that power. The square root of x to the 100th will be x to the 50th. But what about variables with odd powers? In that case, we can factor the variable expression into an even power that is 1 less than the odd power and leave one factor behind inside the radical. X to the 3rd equals x squared times x to the 1. That means we have the square root of x squared, which is x, on the outside, and we leave the square root of x inside. X to the 101th power would be x to the 100th times x to the 1. The square root of x to the 100th is x to the 50th, leaving the square root of x inside the radical. Every time you simplify a variable with an odd power, you will leave one variable inside. Here are some examples. In this first example, the square root of 80 can be factored into the square root of 16 times the square root of 5. The square root of x to the fifth can be factored into the square root of x to the fourth times the square root of x. The square root of y squared does not need to be factored since it is an even power. The square roots of the perfect squares can be written on the outside. The square root of 16 is 4. The square root of x to the fourth is x squared. The square root of y squared is y. The leftover terms go inside the square root symbol. The square root of 5x cannot be simplified. Thus the final answer is 4x squared y times the square root of 5x. Now pause the video and try it yourself. Now that you have tried it, check your work. Divide the odd power into y to the sixth times y to the first. Leave the perfect squares alone. The roots of the perfect squares come out. Y stays inside. The final answer then is 5x squared times y to the third times the square root of y. In the next example, leave the negative on the outside. 30 has no perfect square factors, nor does x. Y to the third can be factored into y squared times y. The square root of y squared is y. Put that on the outside. All the other terms stay on the inside. Final answer, negative y times the square root of 30xy. Pause the video and try the next one yourself. Now that you have tried it, check your work. The perfect squares are 36 and y to the fourth. Take out the square roots of 36 and y to the fourth. For 2y times 6 times y squared times the square root of x. Multiply 2 times 6 for 12, y times y squared for y to the third. Final answer, 12 times y to the third times the square root of x. Now pause the video and try the next two yourself. Now that you have tried it, check your work. The square root of 144 is 12. The square root of x to the sixth is x to the third. The square root of y to the eighth is y to the fourth, leaving the square root of x inside. In this example, leave 5 on the outside. 28 has a perfect square factor of 4. The other two are already perfect squares. Take out the roots of the perfect squares. Leave the square root of 7 on the inside. The answer is 10 times x times y squared times the square root of 7. Now pause the video and try the rest of them yourself. Now that you have tried it, check your work. In this example, the only perfect square is x to the fourth. Take the square root of x to the fourth, which is x squared, and put it on the outside. Leave 5y inside the square root. The answer then is 7x to the third y times the square root of 5y. In the next example, 18 can be factored into the square root of 9 times the square root of 2, and the square root of y to the 13th can be factored into the square root of y to the 12th times the square root of y. The square root of 9 is 3, and the square root of y to the 12th is y to the 6th. This leaves 2xy inside the radical, and the final answer is 75y to the 6th times the square root of 2xy. In this example, factor 8 into the perfect square 4 times 2. X to the 20th and y squared are both perfect squares, so they don't need to be factored. The square root of 4 is 2. The square root of x to the 20th is x to the 10th. the square root of y squared is y, leaving just the square root of 2. Final answer, negative 10 times 10x to the 10th times y times square root of 2. In the final example, everything inside of the square root is a perfect square, so everything can come out. The square root of 4 is 2. The square root of x to the 8th is x to the 4th. The square root of y to the 4th is y squared. Final answer, negative 2 times x to the 4th times y squared. Please always use these notes while completing your homework.